sphere problem. Right. Surface area of a sphere is decreasing at the constant rate of 3 pi square centimeters per second. I mean, they say constant rate, but I mean, if that keeps on going, the sphere will eventually just not be there. At what rate is the volume of the sphere changing? When its radius is 2 centimeters. Okay. Now, so for this, if this were an exam, I'd probably give you the hint. Surface area and of a sphere. The surface area of a sphere is, oops, 4 pi r squared, where r is the radius. And the volume of a sphere is 4 pi over 3 times r cubed, again, where r is the radius. Okay, so I'll give you again a few minutes to work on this on your own, and then we'll go over it. All right, think back to related rates. Think back to how you actually start the related rates problem. Okay, let's do again 5 minutes and some seconds. If you have questions, please ask in the chat. Alrighty. So, talk about this problem. So, who wants to kind of say what they did? Right, Bianca? Okay, so find the givens, get the information provided by the prompt. Okay, good. That's a good idea. I mean, there's actually a few ways you could start this problem, but let's go with that. That's usually how I start the problem, right? I kind of translate everything. Okay, so we are given, let's see, so information. I usually split this up into information and equations, right? Or relations. Okay, so who wants to actually kind of fill in some of this? So you can either give me an equation that we have to use, or you can give me some information from the problem. Let's try to fill in everything. Okay, so dA dt is negative 3 pi. Good. Why did you put a negative, right? This only said 3 pi. Why did you actually tell me negative 3 pi? It's decreasing, right? Make sure you look for words like that, right? It says it gave you the positive number, but they actually told you in English that the surface area was decreasing at a certain rate. So that means dA dt should be negative. So dA dt is negative 3 pi. All right, what else do we have? Bianca says we need dV dt. So this, how I usually write this, I say dV dt equals what, right? The question is at what, it says at what is the volume? I meant to say at what rate is the volume, but I think everyone kind of understood that. At what rate is the volume of the sphere changing? We actually just put in that extra word. At what rate is the volume of the sphere changing? And I want to know that when r equals 2. Okay, so I think that's it for the information, right? I have the first sentence, the 3 pi, that's done. And then the question itself and the 2 centimeter radius. Okay, so I think all the information is there. So what about the equations? Obviously, we're going to use the two given equations, right? But there's more than that, right? Are there any other equations I should be writing down here? All right, let's see. We, all right, so Rohit wrote dA dt equals 4 pi times 2r dr dt. Good. Samir says we take the derivative of the area. Good. So we have to take the derivative of both of these equations, right? That's what Samir said. Take the derivative of the area. And what Rohit actually wrote is that derivative. So dA dt equals 8 pi r times dr dt, right? Don't forget that dr dt by chain rule, right? R is a function of time. And then I have to do the same thing for the volume, right? dV dt is, let's see, the 3 pops out and cancels the 3. So I get 4 pi r squared. Again, dr dt, that's coming from chain rule. Okay, so now the entire problem is parsed out into mathematical equations. Okay, so we can kind of forget about the actual problem statement. We're just focusing on what's on the screen now. What else? What do we do now? What's the next step? Solve for dr dt. Um, okay, we do have to solve for dr dt. And then Samir has dA dt equal to 3 pi. Good. Solve for dr dt. Okay, good. So everything that's actually been said is correct. I just didn't expect you to say solve for dr dt. That's all. But yes, in general, we have to substitute all of this information into these equations. And then, like what Brennan said, the first goal is to solve for dr dt, right? We have to solve for dv dt, obviously, but in the meantime, like as an intermediate step, we need to solve for dr dt. And I did put, this should be a capital R. All right, so let's see. So the first equation becomes if r equals 2, a is 16 pi. That doesn't really help us. V is 8 times 4, so 20, whoops, 32 pi over 3. Again, that doesn't really help us. The third equation gives us negative 3 pi equals 16 pi dr dt. And then the last equation gives us dv dt equals 4 pi times 4, 16 pi, same number. Look at that. Okay. So actually, we can see that these two things are equal, so dv dt is negative 3 pi. But in general, what you would have to do is solve for dr dt and then substitute. But it's just a coincidence, because r is equal to 2, it's just a coincidence that these two numbers happen to be the same. So solve for dr dt, then evaluate dv dt. So doing that arithmetic, we find that dv dt equals negative 3 pi cubic centimeters per second, right? Even though it looks like the same number, it really isn't, right? Because the units are different. So I think the problem actually should have been better if they had given you a different radius, like 5 or 3 or something, just so these numbers don't turn out to be the same. Okay, so that's the end of the problem, right? The volume is decreasing. Um, I guess at what rate is the volume of the sphere changing? So the volume of the sphere is changing at a rate of negative 3 pi centimeters cubed per second.